Integration by substitution. Substitution rule. If u equal gx is a differentiable function whose range is an interval I and f is continuous on I, then to integrate f gx g prime x dx equal integration of fu du. Okay, let's recall what we have learned in differentiation. Okay, in differentiation, there are a few methods to solve differentiation equation. For example, number 1, we will use definition. Okay, if asked by the question. The formula for definition of differentiation or definition of derivative is f prime x equal m tan or the slope of tangent line equal limit h approach 0 fx plus h minus fx over h. Okay. The second method to solve differentiation is by using the standard function. If the function or equation given are very simple, then we can differentiate straight away. There are 8 standard function. Number 1, differentiate constant 0, differentiate x power n, x power n minus 1, differentiate sin x, cos x, differentiate cos x, negative sin x, differentiate tan x, secant square x, differentiate secant x tan x, differentiate ln x 1 over x, differentiate exponent x, exponent x. I hope you guys can memorize all the derivative of standard function already. And then number 3, if the question asks us to differentiate composite function, then we will use chain rule. Okay, for example, here we have y equal ln tan exponent 2x. This is an example of composite function ataupun fungsi gabungan. So, beberapa fungsi bergabung menjadi satu. Okay, here we have 1, 2, 3, 4. So, to solve the differentiation by using chain rule, number 1, differentiate ln, okay, and then multiply. Number 2, differentiate tan, and then multiply. Number 3, differentiate exponent, and finally multiply. Number 4, differentiate to x. So, the third method is when we are given composite function, we can differentiate by using chain rule. Number 4, when we want to differentiate product of two function, okay, ataupun multiplication of two function. So when we have fx equal uv, so u is one function multiplied by v another function, to differentiate f prime x equal uv prime plus vu prime. Okay, for example, here we have y equal x ln x. We can denote x as u, ln x as v. So this is an example of product of the function. So to differentiate y, we can use this formula. Okay, method number 5. When we want to differentiate quotient of two function or bahagi, okay. For example, here we have y equal 4 exponent x over x minus 5. So 4ex is u, x minus 5 is v. So fx equal function u over function v. To differentiate f prime x, okay, we can use this formula v u prime minus u v prime over v square. Or the last method, number 6. We can also use implicit differentiation when variable x and y are mixed up on the right and left hand side of the equation. So when we differentiate, we must multiply dy over dx each time we differentiate the variable y, so that finally we get dy over dx. Okay, all these methods are for differentiation. So for differentiation, by looking at the equation or function given, we can determine which method to use. Okay, berbeza dengan integration. So integration is antiderivative or the opposite of differentiation. Kalau dalam differentiation ada banyak method, kita boleh guna bergantung kepada soalan, tetapi dalam integration tidak. Okay, there is no definition, no composite function, no chain rule, no product rule, no quotient rule, no implicit differentiation in integration. So to solve integration question, okay, when we are asked to integrate a certain function or a certain equation, the first method is to simplify the function into separated term by term. Okay, cara yang pertama untuk selesaikan soalan integration adalah dengan memudahkan function yang diberi kepada sebutan-sebutan yang lebih mudah. Okay, daripada satu fungsi, kita pecahkan dia kepada sebutan pertama, sebutan kedua, sebutan ketiga. Sehingga kita boleh integrate setiap sebutan itu satu per satu. Okay, itu cara yang pertama. Tetapi, kalau function yang diberi tidak boleh dimudahkan, if we cannot simplify the given function, then we will use integration by substitution. Okay, so again, to solve integration, number one, we will try to simplify the given function into separated term by term equation. But if we cannot simplify the given function, then we will use integration by substitution. Okay, let's look at example 9. We want to integrate 1 over 1 minus 2x dx. Okay, using substitution method. Why we must use substitution method? Because we cannot simplify the function. 1 over 1 minus 2x is not equal to 1 over 1 minus 1 over 2x. This is wrong. Kalau terbalik, if it's the other way around, 1 minus 2x over 1, then we can separate to 1 over 1 minus 2x over 1. Okay, this is correct. So because we cannot simplify the given function, to solve the integration, we must use substitution method. Okay, we choose the denominator 1 minus 2x equal u. Okay, because the name of the method is substitution method, so we must do some substitution. Kita akan buat penggantian. So we choose denominator, substitute by u. Differentiate u in terms of x, we get du over dx. Differentiate 1, 0. Differentiate negative 2x, we get negative 2. And finally, we get dx equal du over negative 2. Okay. So we want to solve integration of 1 over 2, 1 over 1 minus 2x dx. Okay. Let's do the substitution. 1 minus 2x is u. So 1 over u, and then what's left is dx. Dx, we will substitute by du over negative 2. Okay, we can factorize negative 2, and we are left with 1 over u du. integrate 1 over u is ln u plus c. And then for final answer, replace u by the original. Okay, originally u is equal to 1 minus 2x. So negative 2 ln 1 minus 2x plus c. Now let's solve example 12. We want to integrate 9r squared over square root 1 minus r cubed by using substitution method. So again, why must we apply substitution method? Because we cannot simplify the function. Okay, we cannot separate the square root. Okay, step number 1. Choose the equation from denominator to equal u. So u equal 1 minus r cubed. Differentiate u in terms of r, we get du over dr. Differentiate 1, 0. Differentiate negative r cubed, negative 3r squared. Okay, now we want to do the substitution. Okay. Originally, we have square root 1 minus r cubed, but we replace 1 minus r cubed by u. Square root u. Okay, next we want to substitute dr. We can get dr from here. So dr equal du over negative 3r squared. Okay, let's substitute. So we have replaced 1 minus r cubed. Okay, now we want to replace dr. Replace dr by du over negative 3r squared. And then let's put 9r squared. 9r squared. We can simplify 9r squared and negative 3r squared. 9 over 3 is 3. So we get negative 3 and we can factorize. So what's left is 1 over square root u du. Square root u is equal to u power 1 over 2, and we can bring them up. So u power negative 1 over 2. So now we can solve the integration. Integrate u power negative 1 over 2. Negative 1 over 2 plus 1. 1 over 2 over 1 over 2 plus c. Mm, 2 multiplied by negative 3 is negative 6. U power 1 over 2 is square root, and then replace u by 1 minus r cubed plus c. Next, let's discuss example 14. We want to solve the integration of 7 sine 3 theta plus 5 d theta by using substitution method. So again, why must we use substitution method? Because we cannot simplify the function. Okay, we cannot separate 3 theta plus 5 because this belongs to sine. Okay, choose one thing to become u. So let's choose u equal 3 theta plus 5. Differentiate u, du over d theta. Differentiate 3 theta, we get 3. Differentiate 5, 0. So du over d theta equal 3. Now let's do substitution. Okay, 7 is the coefficient, so we can factorize 7. Okay, sine. Originally we have sine 3 theta plus 5, so replace 3 theta plus 5 by u. So we get sine u. Okay, we have factorized 7. We have substituted theta plus 5 and we are left with d theta. Okay, we can get d theta from here. So d theta equal du over 3. Okay, replace d theta by du over 3. We can also factorize 3, 7 over 3. So we are left with sine u du. So now we can solve the integration. Integrate sine u is negative cos u plus c. As for the final answer, do not forget to replace u by 3 theta plus 5. So negative 7 over 3 cos 3 theta plus 5 plus c. We want to integrate exponent to x multiply exponent to x plus 1 power 5. So remember, we do not have product rule in integration. So what we can do is that we can use substitution method. For substitution method, we choose u equal exponent to x plus 1. Differentiate u in terms of x, we get du over dx. Differentiate exponent to x, we get exponent to x over 2. Differentiate 1, 0. So now let's do the substitution. Okay, let's start from exponent to x plus 1. So integrate, replace exponent to x plus 1 by u. So u power 5. Next, I want to replace dx. We can get dx from here. So dx will equal to 2 du over exponent to x. And then let's insert exponent to x. Okay, here we can see that we can simplify exponent to x and exponent to x. We can also factorize 2. So we are left with the integration of u power 5. Integrate u power 5. Okay, u power 6 over 6 plus c. We can simplify 2 over 6. And then as for the final answer, do not forget to replace u by the original. So exponent to x plus 1 power 6 over 3 plus c. Next example, we want to integrate exponent to t over 1 plus exponent to t dt by using substitution method because we cannot separate the equation. We choose denominator as u, so u equal 1 plus exponent to t. Differentiate u in terms of t, we get du over dt equal differentiate 1, 0. Differentiate exponent to t, we get exponent to t over 2. Okay, and then let's substitute. First, I want to start from 1 plus exponent to t. So, we have u. Next, I want to substitute dt. We can get dt from here. So, dt equal 2 over exponent to t du. So, let's replace dt by this. And then, insert exponent to t. And here we can see that we can cancel out exponent to t and exponent to t. And we can also factorize 2. So we are left with the integration of 1 over u du. Integrate 1 over u, we get ln u plus c. As for the final answer, replace u by the original. So 2 ln 1 plus exponent to t plus c. Next question, we want to solve the integration of x squared multiplied by square root x minus 1. We have to use substitution method because we cannot simplify or separate the function. So we choose u equal x minus 1. Differentiate u in terms of x, du over dx equal differentiate x 1, differentiate negative 1, 0. So now let's substitute. Let's start from x minus 1. So we have square root u. Next, I want to substitute dx. We can get dx from here. So dx equal du over 1. Okay, replace dx by du. Okay, du and du over 1 is basically the same thing. And lastly, we want to replace x squared. So how can we replace x squared? We can get x squared from here. U equal x minus 1, therefore x will equal to u plus 1. And then x squared equal u plus 1 square. We can expand u plus 1 square. U square plus 2u plus 1. Tak muat. Then multiply by square root u. Square root u is equal to u power 1 over 2 du. Now that we have replaced everything in terms of u, to further simplify, we can expand. U square multiplied by u power 1 over 2. So u multiplied by u, we must add the power. 2 plus 1 over 2 equal 5 over 2. So u power 5 over 2 plus 2. U power 1 plus 1 over 2. Okay, 1 plus 1 over 2 is 3 over 2. And lastly, 1 multiplied by u power 1 over 2, u power 1 over 2 du. Here we can see that all the terms are separated. We have first term, second term, and third term. So we can integrate one by one. Okay, let's start with integration of u power 5 over 2. 5 over 2 plus 1 equals 7 over 2. So 7 over 2 over 7 over 2 plus 2u. 3 over 2 plus 1 is 5 over 2. So power 5 over 2 over 5 over 2 plus u. 1 over 2 plus 1. 3 over 2 over 3 over 2 plus c. Now, for the final answer, let's simplify and then do not forget to replace u by x minus 1. We want to integrate exponent sin x cos x over 2 plus exponent sin x dx. So again, because we cannot simplify or we cannot separate the function given, we use substitution method. We choose the denominator as u. So u equal 2 plus exponent sin x. Differentiate u in terms of x, we get du over dx equal, differentiate to 0. Okay, now we want to differentiate exponent sin x. This is a composite function. So number 1, differentiate exponent, and then multiply number 2, differentiate sin x. Differentiate exponent, we get exponent sin x, multiply differentiate sin x is cos x. Okay, now let's do the substitution. Substitute 2 plus exponent sin x by u. And next, I want to substitute dx. We can get dx from this equation. So dx equal du over exponent sin x cos x. And lastly, let's insert exponent sin x cos x. From here, we can see that we can cancel out exponent sin x cos x, and we are left with 1 over u du. So the integration of 1 over u is ln u plus c. As for the final answer, replace u by 2 plus exponent sin x plus c. We want to integrate x secant square for x square minus 5 dx. So let's use substitution method. First, we must choose u. I choose u equal 4x square minus 5. Differentiate u in terms of x, du over dx. Differentiate 4x square, we get 8x. Differentiate negative 5, 0. So let's do the substitution. First, I want to substitute for x square minus 5. So I get secant square u. Next, I want to replace dx. I can get dx from here. Dx equal du over 8x. So replace the x by du over 8x. And finally, let's insert x. Here we can see that we can cancel out x. And we can factorize it. So we have 1 over 8 integration of secant square u du. 1 over 8 is the coefficient. Integrate secant square u is tan u plus c. And as for the final answer, replace u by 4x squared minus 5.